Alexa, turn on the cabinet lights. Alexa, turn off the cabinet lights. Hello guys, welcome to another episode at IB Electronics World. In this episode, I will explain how you can turn on a light by using the Alexa and by using also the ESP8266. Here I have included the mandatory libraries for the FOMO, ESP, ESP8266 Wi-Fi and Arduino. Then I have defined the serial baud rate. Then I have assigned as a constant integer the transistor pin 5, which is the D1 pin. And then the name of the virtual device is a constant again, which is device 0. And the name is cabinet lights. Then very important, you need to define the Wi-Fi ID, which is on your router back. And then you need to define the Wi-Fi password. Again, it's on your router. And then in the setup, we just setting up the serial port. We are setting the transistor pin as an output. And then we say with a display message that the setting up Wi-Fi. And then we are setting up the FOMO and adding the virtual devices. Again, by saying FOMO on site and then callback, which the callback goes to that function here, which is called callback. And I have created a statement which is if else. In that case, if we meet the state equal to 1, we are going to turn on the light, and if it's not, we are going to turn off the light. And finally, it's the Wi-Fi setup, which again, we are setting up the Wi-Fi and we print out a nice message. Going back to our design, on the left hand side we have the voltage regulator LM7805 and we have a 12 volts input and it gives us an output 5 volt. We are using two decoupling capacitors, one for the input here and one for the output here. And the main reason we are using these two capacitors is to provide a low impedance, high frequency path at the input and the output of the regulator. And both capacitors are needed in order to suppress the high frequency noise from the source. And the output of this regulator is connected to the V-in of the ESP8266. And then we have the D1 pin, which is set as an output, and we have connected a 1K resistor, which is connected to the base of the NPN transistor. Just a brief explanation why we are using that 1K resistor. So we are using in order to limit the excessive current to the base, and also if the transistor is on, then the base voltage here is 0.7 voltage higher than the emitter point here. And if you want to find out the current which flows through this resistor, you need to do V in, which is 5 volts here, minus 0.7 volts divided by the R. So if you have a different value, you will use a different number here. And then on the transistor, on the collector, we have connected a flyback diode, which is connected across to the relay in order to protect the reverse current. And also on the relay, we have connected two pins which are separate, and we are going to use the plus voltage plus of the LED cable lights and the minus here. And these are the components for the hardware. On the left hand side we have the ESP8266, then we have the voltage regulator, two capacitors, one transistor, one resistor, one diode, one relay, and a prototype board. And now
As you can see, we have placed all the components accordingly, and the next step is to cut the board and connect the LEDs, and actually we have implemented the project. And now I have cut the prototype board and I have connected the LED cable lights. And this is how I have connected the LED cable lights on the cabinet. And in the back side I have connected the PCB, as you can see here. And the LED cable lights are around the cabinet.
Thanks for watching. Don't forget to like this video and don't forget to subscribe.